There are a couple of different units for measuring angles, and probably the one that you're more familiar with is degrees. Down here I have a unit circle, so that is a circle whose radius is 1, that is centered at the origin. And here we have this convention that if you start here at the positive x-axis and you do one full rotation, we say that that is 360 degrees. So starting from here, if you don't rotate at all, we would say, well, you've rotated 0 degrees. And if you do one full rotation, you would get 360 degrees. So these are two different angle measurements, but they're really referring to the same location. If you rotate 0 degrees or 360 degrees, you end up at the same spot. Here in example 1, I have a few other degree measurements that I'd like to label on this unit circle. So we've already figured out where 360 degrees is located. Where is 720 degrees? Well, if you start at 360 degrees and you rotate another 360 degrees, the sum of those two is going to be 720. So that means we're at this location on the unit circle. So the location of not rotating at all, doing one full rotation or two full rotations take you to the same location. All right, where is 180 degrees? Well, if you do one full rotation and you get 360 degrees, if you do half as much, that would be over here. So this is going to be 180 degrees. So that is half of a full rotation. Okay, so we've taken care of these. Where is 90 degrees located? So that's going to be halfway between 0 degrees and going to 180 degrees. So 90 degrees would actually give you a right angle. So that means we started here and we ended up here. So I'll label this as 90 degrees. All right, so what about 270 degrees? Well, here we subtracted 90 to go back from 80 to 90 degrees. If you start here and you add 90 degrees, that would take you to 270 degrees. So that's going to be this location here. So these measurements are really important just because they refer to what is happening on the positive x-axis and the negative x-axis, and the positive y-axis and the negative y-axis. Here we have three other angle measurements in degrees. They're not going to line up with an axis, and they're all going to be located over here, and they're worth labeling on this circle. So to start with, that would be 45 degrees. So this is going to be halfway between 0 and 90 degrees. So I'll actually draw this one in a little bit. So it's going to be something like this. So here is 45 degrees, halfway in between 0 and 90. 30 degrees, that's like a third of a rotation here. So it's somewhere between, 45 and 90. So maybe I'll draw that in like this. So this is roughly 30 degrees. And the last one, which is 60 degrees, well, that'll be going back 30 degrees from 90. So maybe somewhere like right about there, I'll draw in, okay, this is 60 degrees. So for this example, it's just good to be familiar with what's happening on the axes, but also these three angles over here are important too. In example 1, we saw that if you start on the positive x-axis and you rotate in a counterclockwise direction, that's some positive angle measurement. We're going to use the convention that if you rotate clockwise, we're going to give that a negative sign in front of the angle measurement. So where would negative 90 degrees be located? If this is our starting point and you went positive 90 degrees, it would take you up to here. So negative 90 degrees just means you go in the opposite direction, and that would take us to right here. So I'll just label this as negative 90 degrees. It's also the same location as positive 270 degrees. All right, well, what about negative 180 degrees? Well, that would be half a rotation in the opposite direction. So that's going to be right here. So I'll put, okay, this is negative 180 degrees. It just so happens that that is the same location as positive 180 degrees. If you go half this way or half this way, you're ending up at the same spot. Okay, negative 270. So that's going to be going 93 times, but in the opposite direction. That would take me to here. So this is negative 270 degrees. Now for these last two, I guess I'm not 100% certain where these angle measurements are going to be on this unit circle. This one's kind of confusing just because the number itself is really large. Here's how I like to think about it. I first just ignore the negative, and I think of 630 degrees. And I know the negative is telling me that I'm just going in the opposite direction, the clockwise direction. I know I can subtract a full rotation from this, and it'll make the number 630 smaller and easier to see where we actually end up. So I guess what I mean is, if I take 360, a full rotation, and I subtract that away from 630, what I'm left with is 270 degrees. What does all of this tell me? It tells me that if you rotate clockwise 630 degrees, that's the same thing as rotating one full turn, or 360 degrees, and then rotating another 270 degrees. Those two things are equivalent. But written this way, it's easier to see where it is located on the circle. So let's do it. If I start here, I'm going to go a full rotation in the clockwise direction. That takes care of this. Now I'll go 270 more, which takes me right to here. This is going to be the location of negative 630 degrees. So I'll put that up here. So these two angles are referring to the same spot on this unit circle. Let's do a similar idea for this one, negative 135 degrees. Where is this located? I think my approach will be similar, where I'll ignore the negative and just think about a positive 135. I know the negative is just telling me to go in a clockwise rotation. This time, I can't really subtract 360, a full rotation from 135, because you're taking away too much. So I should subtract something smaller that I'm familiar with. Even subtracting 180 is going to be too much, but subtracting 90, that's not going to be a problem. So that's the number I'm going to use. I know 135 is going to be somewhere over here, so I'll take 90 away from it and reason it out. So if I subtract 90 degrees, I get 45 degrees. This tells me that if I rotate clockwise 135 degrees, that's the same thing as first going 90 degrees clockwise, followed by another 45 degrees. So if I start here, this is 90, this is 45 more to roughly here, and I'm going to draw this in as my angle. Doesn't have to be perfect, but it's roughly here, 135 degrees. So for smaller angle measurements, it's relatively simple to see where they are on the unit circle. If the numbers are larger, you can subtract away full rotations, or even something like 90 degrees or 180 degrees if it helps you figure out where it's located. There is another unit that is used to measure angles, and that's called a radian. I'd like to describe what it is by going back to the unit circle, which is a circle of radius 1 here centered at the origin. To start with, if we have a circle, the circumference is the distance around this circle. And if you recall, there is a nice formula that tells you the circumference if you know the radius of your circle, and it's c is equal to 2 pi r. Here, since we're working with a circle of radius 1, if we put 1 in place of r, we get that the circumference of this particular circle is 2 times pi. This is useful for defining a new unit of measurement because if you start here at the positive x-axis and you do one full rotation going counterclockwise, we call that 360 degrees. You could also call that 2 pi, equating it to the distance that you traveled around the circle. And this is what we mean by radians, and this will be abbreviated RAD. So if you see 360 degrees, that'll be the same thing as saying 2 pi radians. That means you started here and you went all the way around this circle. So since we have this written over here, it might be nice to label, well, what is this angle measurement in radians? What would this angle measurement in radians be? And so on. So let's try to figure that out. Okay, if you start here and you do a full rotation, that's 360 degrees. Half as much would be 180 degrees. So that's over here. So you can just take 360 and divide it by 2. Well, you can do the same thing to your radians. You could take 2 pi and divide it by 2, and what you get is pi. It looks strange, but 180 degrees is going to be the same thing as saying we went pi radians around this circle. Likewise, up here, we knew that this was a 90-degree rotation. So I'll put 90 degrees. Well, what would that be in radians? Going from here to here, we took half of 180 to get 90. If we take half of this, the best way we could write that would be pi divided by 2. And that is radians. I think the last spot to consider would be, well, what's this down here? What we said last time is to go from this spot to this spot, you could add 90 degrees to 180, and we did, and we got that this is 270 degrees. But what is that in radians? So here we took 80, we added 90, and we got 270. What we could do here is take pi, add pi over 2 to get the value that goes here. Let's actually do that off to the side. So we have pi radians, and we're going to add pi over 2 radians. Well, we can get a common denominator. Let's see, that's 2 pi over 2 radians plus pi over 2 radians. And 2 pi over 2 plus pi over 2 is 3 pi over 2. So here are 4 important radian measurements off of the unit circle. In example 3, what I'd like to do is convert these degree measurements into radians. Now, we saw on the previous slide that 360 degrees is equivalent to 2 pi radians. If you divide both sides of this by 2, that's the same thing as saying 180 degrees is equal to pi radians. We can use either of these to convert back and forth between degrees and radians. I'll choose the second one that I wrote only because it's more simplified. We cancel the factor of 2. So to start with, 45 degrees. I know where that is located on the unit circle. That would be here. But what is this in terms of radians? How can we figure that out? To convert this, you can take 45 degrees and multiply by a conversion factor, which will come from this equation. The idea is you want to divide by degrees to cancel degrees and multiply by radians so it's left over. I'm going to multiply this by pi radians over 180 degrees. So this is called a conversion factor. Since these two things are equal, in a fraction, this is really equal to 1, and multiplying by 1 does not change the value, but it will cancel the units that we don't want. The degrees cancel, and we have radians left over. If we multiply the numerators, we get 45 pi. If we multiply the denominators, we get 180. And we also have radians that was not canceled. So here's the answer, 45 pi over 180. Of course, this can be simplified. 45 goes into itself once and into 184 times. So we have pi over 4 radians. So this is an important connection. 45 degrees is the same thing as pi over 4 radians. So I'll put pi over 4. Let's do the same thing for 30 degrees. All right, so here we have 30 degrees. I know that's located about here. There's 30 degrees. But what is that in terms of radians? So I take the degree measurement, I multiply by my conversion factor, which is pi radians over 180 degrees. The degrees cancel, and I have radians left over. If I multiply the numerators, I get 30 pi over 180 radians. Now, 30 goes into itself once, it goes into 180 a total of 6 times, and we've done it. 30 degrees is equivalent to pi over 6 radians. So I'll put that here. We have 2 others. All right, so here is 60 degrees. All right, so we have 60 degrees. I want to convert that to radians. So I multiply by pi radians over 180 degrees. By doing this, we cancel degrees. We have radians left over. And in fact, we have 60 pi over 180 radians. The 60 goes into itself once. It goes into 180 a total of 3 times. And this means our answer is pi over 3 radians. So 60 degrees is equivalent to pi over 3 radians. Now we have one more. I'll put that on another slide just because we're running out of space. So what about negative 90 degrees? I know it's located right here. So this would be negative 90 degrees. But what is that in radians? We'll multiply by pi radians over 180 degrees, and this will cancel the degrees, and we multiply across, we get negative 90 pi over 180, but radians is the only unit that's left over. Okay, 90 goes into itself once, it goes into 182 times, and this means the answer is negative pi over 2, but now our answer is in radians. So that is right here. Okay, great. And that makes sense. Pi over 2 means 90 degrees, which means if it was positive, you'd go up here. The negative is just indicating that you're going this direction in the clockwise rotation direction. All right, in example 4, I want to graph where this radian angle is on this unit circle and then convert it to degrees. So before we convert it from degrees into radians, we can also convert from radians into degrees. So where is 3 pi over 4? Well, I know where pi over 4 is. Like last time we did pi over 4 was a 45-degree angle. So, like right about here. It might be useful to first convert this into degrees if you like thinking of it that way. So let's actually take that approach. I'm going to convert this into degrees. Let's see what that looks like. So we take 3 pi over 4, and just for some emphasis, I'm going to put that this is radians. I'm multiplying by, all right, this time I want to cancel the radians, so I'm going to put radians in the denominator, and I'm going to put degrees in the numerator. We saw before 180 degrees and pi radians were equal. So if you put them in a fraction like this, we call it a conversion factor because it's really equal to 1. But what happens is we can cancel the radians, and what is left over is degrees in the numerator. So if we now multiply the numerators, maybe I'll do this in a couple of steps, but you get 3 multiplied by pi multiplied by 180, and that's degrees, and this is all divided by 4 and pi. So I'm just like directly multiplying everything across except for the radians because I canceled it. And I'm doing the same thing in the denominator. Radians is gone, so I just have a 4 times pi. Okay, some stuff does cancel. Pi cancels. 4 does not go into 3, but I'm pretty sure 4 goes into 180. In fact, it goes in a total of 45 times. So 4 goes into itself once. It goes into 180 45 times. Here's what we have left over. We have 3 times 45 times degrees, and then we have just 1 in the denominator, which I'm not even going to write. The product of these is 135, and that's now in degrees. So where is 135? The way I think of 135 is, okay, first you go 90 degrees, and then you add on 45 more degrees. The sum of those two is definitely 135. And if I start here, this is first going by 90, and then this will be 45 degrees more. So this angle, that right there, is going to be 135 degrees. And it just so happens that that is equal to 3 pi over 4 in terms of radians. Is there a way that we could have seen where this was equal to instead of converting it into degrees? And the answer, it turns out, is yes. So here's another way to think about the problem. Do we know where pi over 4 is? And we do because I know it's the same thing as 45 degrees. So here's pi over 4. If you add on another pi over 4, that means you go another 45 degrees. If you then add on another pi over 4, you've gone 45 degrees more like this. And that's the same thing as saying, oh, well, we have 3 pi over 4. When I look at 3 pi over 4, I know the denominator means, okay, 45 degree angle. And the 3 is telling me, well, how many times am I adding by pi over 4? 3 times. 1 pi over 4, 2 pi over 4, and 3 pi over 4. Either way you think about it in terms of degrees or in terms of radians, you can reason out where it is supposed to be located on the unit circle. Okay, example 5. Same idea as the last one where I have an angle measurement, but it's in radians. I want to figure out where it is on this unit circle, but I also want to convert it into degrees. So I think my first step is going to be to actually convert it. In terms of degrees, it might be easier to find on this unit circle, and then we'll go from there. So what I'll do is take negative 7 pi over 6, and note that this is in radians. If I want to write it in terms of degrees, I need to use a conversion factor. Well, 180 degrees is the same thing as pi radians. So multiplying like this, it'll cancel the radians, and it leaves us with something in degrees. If I multiply all this together, I get negative 7 pi and then 180, and that's in degrees. In the denominator, I have 6 and I have pi, and I have nothing else. It'd probably be a good idea to simplify this number. So I can simplify by canceling pi, and I know that 6 goes into 180. Just be careful here to divide that, and we get 30. So this is negative 7 times 30. I don't need the denominator because the denominator is now 1, and this is all degrees. or more simply, negative 210 degrees. So that means I am going backwards because it's negative. And I know this is negative 180, so going backwards would be negative 180. So it's going to be a little bit past this. I'm not 100% certain like how much past that. So what I'm going to do is take this negative 210, and I'm going to focus on just the positive of it, 210. If I take away 180, what I have left over is 30. This is telling me that, okay, going negative 210 is the same thing as going backwards, negative 180, followed by 30 degrees more. So let's actually write that out. Negative 210 degrees is the same thing as going backwards, negative 180 degrees, followed by another 30 degrees. So, we'll sketch this in. So that's 180. Adding a 30 is like maybe roughly about here. So I'll sketch that in. Let's see, something like that. So this is the location of 210 degrees. Now that is equivalent to negative 7 pi over 6. So here it is in terms of radians, and here it is in terms of degrees.